All right, welcome back to Good Choices by checking the mic check. Mic check 1 2 looks good. So I'm gonna keep going on this automate your network series. I didn't get through the book that much, so let's keep going on that. So I kind of changed how I'm gonna do this. I just want to get through it as much as I can. So I'm gonna uh, at some point maybe switch back over to using VS Studio Code, but for right now, I'm just going to really simplify things. So I've got all my files here, and then I'm going to go in through Bash like that, and then I'll use all my version control here, and then for any editing files, for reading the book, I'm just going to open it up so we can see if I do a Control S, it saves my space, and then if we go in here and let's say we want to edit one of these templates, or so we want to edit a playbook. So now we've got these YAML files, and I can just open it with Notepad++. Yep, so I can just select Notepad++, open, always, for YAML files. And there we go. I've got the syntax highlighting, and most importantly, I don't have something popping up asking me if I want to update Notepad++. I don't have some menu popping up. I'm not distracted, and for me, I do have some struggles with like ADHD, as I talked about on this channel, and like general focus issues. So like the number one most important thing for me is just to not get distracted, and we can see, Notepad++ is a great program for that. Visual Studio Code, let's just open it up right now and see what happens. All right, I uninstalled it. I don't even have it on my system anymore. So Visual Studio Code, we'd have to install it. The installation takes a long time. We'd have to install our plugins, but just using Notepad++, we're all ready to go to start programming. Okay, so I've got the book open, so let's continue reading the book. Next section is Linux on Windows 10. The Linux requirements should not deter the organization from pursuing Ansible. So Ansible only runs on Linux. There's no Windows version for it. The enterprise may not support Linux. The network team may not be very familiar with Linux, or it may be a purely Microsoft shop. Linux on Windows is a relatively new supported feature from Microsoft. However, Ansible has been proven to run under Windows using the latest version of Windows subsystems for Linux, or WASL. That's what I'm using, and the Linux and the Ubuntu distribution for WASL, which is also what I'm using. So first, install WASL, and I won't be doing this because I already have it installed. But if I didn't have it installed, I'd go to Control Panel, I'd pick Programs. And then I'd go to turn Windows features on or off. Okay, and then you would scroll down for Windows subsystem for Linux. Click that whole thing. Click OK. And then now you choose the distribution you want. So you'd be choosing Ubuntu. There's also like Kali Linux is like a big one. I think that's like the other really big one, and that comes bundled with like networking tools, things where you can learn about like security. But Ubuntu is the one I typically use. So it's just like a good general all around one that's not like hyper specific to anything. All right, so then you launch Ubuntu and install Ansible. So I believe we did that in the lab. Let's take a look. Now, I could install Lansible. I could install Ansible on my home device. Doing this in WASL. So like here's WASL here. But then I would not have the ability to actually do things in a virtualized network. So where I need to install Ansible is on my server here that I will be using to administer and manage my virtual network. So Ansible goes on here, which luckily is a pure installation of Ubuntu Linux directly on the hardware. It's not a virtualized version in Windows, so I really don't need to worry about this. So this is how you get it. You can also clone this down. So clone the automate your repository network into the Ubuntu environment. There we go. Change to the production. So you know what? I probably need to do this on my lab device. So let's follow those steps. Okay, and it's, you know what? I'll demo something pretty awesome. All right, I'll pause and be right back. It's taking forever. All right, I'm back. Let's see how this is. Okay, we're there now. So we can use Visual Studio Code here. It was kind of more of a nightmare on my virtual, but we can even see, like, look at how long that took to come up. If we just hit the terminal, look, the terminal is actually up before that came up. And, you know, we just, we hit it like well after. So let's do what we need to do. We're going to go to Documents. And let's get rid of this no hang up out file. First of all, let's tail it. Okay, so we don't have that file ever growing, so that's not going to be a problem. Perfect. Let's go into the repository, which is in Documents. There we go. And now what we can do, so we got to get status here. Everything's good. We got an ls. So we can see we don't have the updated version, so we can just do a git pull. And there we go. Now we can see it. It comes up in here. But see how easy that is. Like, don't worry about using the most sophisticated tool right away. Worry about what you need to get the job done. I've said this a lot in my last video. You know, just have this mentality where, like, you know, you're trying to get it done. You're trying to get it on time, and anything that gets in your way and prevents you from working on it, even, you know, if it can give you a slight edge later, you know, once it really starts, you know, for the next project that comes along, okay, allocate some time to figuring out how to get these tools working. But for this project here and now, with the deadline coming up next week, work on the code. Do not work on anything like setting up a Visual Studio extension. Once your project is complete and before you're assigned the next one, get all that optimization stuff working. But for now, get the project done, even if that means it takes you 5 hours when if you had everything all set up optimized, it would only take you 2 hours, because, you know, if that optimization only takes you 3 hours, great, but, you know, as we saw, it can take you 10 hours, and in that case, you're just not, it's just not working. And your frustration, like, you know, if you're spending 5 hours working on something and it's just like you're in a flow state, you're killing it, you're loving it, you know, you spend 1 hour and it's just a painful nightmare. It's like, you know, it's a day, like it all fits in with the day. So like optimization to some level just doesn't matter unless it's like orders and orders and orders of magnitude better. All right, so we've got this pulled down. So now let's keep on going with the book. So okay, so we did a git pull. We've got everything good. So now we're going to change to the production folder. All right, and then we're going to explore the repository. Yep, looks good to me. We've got the playbooks, everything. We've got host vars. That's a big one. So we'll look into that some more. All right, so here's all the devices on the core. So now this we can use this to design our network. So we have a core device here, a distribution uh, device. So one thing we can do is go to the GNS3 folder. So we go cd etc GNS3, or sorry, if we do a find or like a sudo find GNS3 like that, um, and then we just look for like the images folder for GNS3. So just like the really, I don't know why it's saying GNOME, but oh, because we're not doing it by the name. Okay, there we go. So I it might be in media. Let's try it. Uh, okay, so it's not there. Um, let's do that search again. I want to basically just have all my image files listed out nice and clean so I can feed it into ChatGPT, and I can have ChatGPT make some choices for me about what oh, you know what? You know why this isn't working? I have to do this on my home lab. Okay, so yeah, the images are on my home lab. They're not on the virtualized machine here. So oh, you know what? So it might be where I thought it was. So I thought it was in like etc GNS3. Is that there? Nope. I thought it was in like home GNS3. Is there like a dot GNS3? Nope. Oh, you know what? This isn't my. This is Wassel. This isn't even my home lab. Yeah, see how complicated this can be. So like, yeah, using Visual Studio Code can be great because then you don't get everything confused like that. If your team's using it, yeah, somebody should be able to help you get things going. But as I said, if the thing needs doing, do the thing and don't do anything else but the thing. So now what we need to do is do that. I'll do that same search. That should be fine. So find dash name GNS3, and then now this is my lab. Oh, gotta type the password incorrectly. Okay, so now it's where I thought it was. So let's go there. All right. So we got the GNS3.ini. We might get some more information about like, yeah, here we go. This is exactly what I want. So we're gonna cd into that. Oh, you know what? Yeah, that's just the okay, something was going wrong with that. Let's do cd ios. Okay, cd iou. Okay, cd qemu. There's all the images. So perfect. We're gonna grab all these. And then we're gonna go to the AI. We're gonna paste them all in. All right, and then what we're gonna say to the AI is these are all the images I have in GNS3. These are all my GNS3 images. Select the best images to use for a virtualized So yeah, this is in my repo. So we're gonna open the repo, which is in Wassel here. So we'll go to ls, then we're gonna go to production, and then we're gonna go to host vars. So now we've got this one kind of So these are our hosts. If we print out hosts, we go back and we print out hosts. These are all of the hosts we've got. So these are the host names of our devices. So let's do this. So we're gonna say for each of the hosts in my network. So we're gonna say these are all my so above are all my GNS. Below are all of the hosts I will have in my virtualized lab network. So assign an image to use. Assign the most appropriate image to use for each of the devices hosts on my virtualized network. Boom. Isn't that amazing? What a world we live in.
Certainly. Your virtual lab setup has a hierarchical architecture covering campus, data center, DC, and wide area network. Want layers.
Isn't that amazing?
I'll try to map to most appropriate GNS3 images you have for these devices, considering your goal to master network automation and better understand network designs. Campus layer core. Bias of vendor private GYNM. VMBK. SPA.
What a world we live in. Seriously.
QCOW2 for a core router and a campus network. An IOSV image can give you robust routing capabilities. Campus DIST01, DIST02. VIOS LAB4. 25. 0F. VM Priestess EOS can offer flexible options and allows you to experiment with advanced features. Campus ACCESS3750, ACCESS01, ACCESS02. VIOS _L2 at vendor private GYNM. 03. 2017. QCOW2 layer 2 functionalities are essential at the access layer. The iOS VL2 image can simulate this environment well. Campus ACCESS3850, ACCESS03. Exos VM _V3. 7. 1. 1. QCOW2 Extreme XOS is known for its robustness in handling edge network functionalities. DC layer DCN7K GGDC01N7K1, DC02N7K2. Nexus 950OB. 9. 3. 3. QCOW2 for simulating Nexus 7K aggregation switches in a data center environment, the Nexus image would be suitable. DC5K DC01N5KA, DC02N5KB, DC02N5KA, DC02N5KB. Cumulus Linux 4. 2. 0BXAMB64 Camu. QCOW2 Cumulus Linux can offer realistic DC switch simulation. 1 layer WAN ISRWAN ISR01. VIOS at vendor private GYNM. VMBK. SPA. 156 to 2. T. QCOW2 you can use the same Cisco IOSV image to simulate an ISR router. WAN ESWWAN ESW01. Papteli EDGE19. 2. 0 generic x86.
I mean, isn't this absolutely just amazing? This is just amazing. Okay, it hallucinates, so I don't know if they actually are, but if it was just up to me, I would just, I don't know if this would be a lot of work just to think about what to use it. I don't have to think about this anymore. I'm basically outsourcing mental, work. This saves me a lot of work. All right, so let's get the core for our, this is for our campus. So we're going to use the VIOS image. So let's do that. And I wish I could see the actual image names. So it's VIOS. So I'm pretty sure that's one of my Cisco images here. I wish I knew what this was. Oh, here we go. So yeah, this is the disk image name. So it's VIOS underscore L2. Let's see if that matches. It does not. So, all right. So let's just drop the other VIOS images so that we can see which one it actually is. It's probably this one. Yeah, VIOS, yeah, 156-2. All right, so these are for our core. So for a core router in a campus network, an iOS V image can give you robust routing capabilities. So let's use that. And we're going to call it core. So we're going to rename it, change hostname to core. And then we'll call it VIOS maybe, or iOS V. Core iOS V. We'll call it 1-core of iOS V. We can't do that. So let's call it core iOS V -1. I think we can't have spaces. So let's call it core 1. All right, and then let's drop another one. Oh, you know what? We don't have to. This is the thing. Like, you know, it's in our host file. We don't have to give it a host name. So yeah. Here's the campus. Oh, you know, we're just using one core. So we just call it core in all uppercase. And then that's the name. So we've got some okay, so let's do this. Based on the hosts file, print out a list of the devices I will need in this list for each entry in this list. In this list, list the host name of the device and the image file needed. All right, here we go. Perfect. So, yeah, okay. So for the campus layer core, we're going to have one named core. We got that. All right, so now we need 2 devices for the distribution layer. This is going to be the VEOS image. All right, so we'll set that up. This is what a world we live in. Seriously, this is like absurd. And like the thing is, like, you know, I feel like what you get, like what you can do now that you couldn't really do before, is you can just take the cheapest, most garbage equipment you can find on eBay, and like you can put it all together now, because it's like this like it's like, yeah, I just feel like ChatGPT is like really under, like the things you can do with it are like so insane. It's like the only limitation is like, I mean, first of all, like, you know, this is just the only limitation of like LLMs is like what you can there's like prompting the LLM. All right, so now we're gonna do VEOS. I think that's an extreme. I'm not sure. Let's see what VEOS is. Oh, that'd be fun if they have us use extremes. That'd be really fun. Oh no, it's an Arista. Okay, well that's even better, because Arista's especially in, I'm surprised this is part of the campus, but I think Aristas are like really used a lot in the real world. So this is called capital DIST and then 01. Right, and then we've got one capital DIST02. Oh man, look at this. This is so cool. This is literally like the coolest thing I've done in a while. All right, and now we need the access layer. Um, we're gonna have three devices in the access layer. Um, Now one thing I'm not sure about is like why this is the case. So like, so why is there? So why use a different image for? And okay, so why use a different image for x is 0, 3, and why is it assigned a number? Oh yeah. Let's just ask it that. Yeah. Okay, so you can have yeah, like if you want, okay, perfect. So like yeah, you can have some extra functionality at the access layer if you have like that one device. Now you have to put the device somewhere, but you know, if like for example you have IP phones and you need PoE in one part of your this is campus, not the data center, but in one section of your campus, you could put a cheaper switch, in places where you don't need the PoE. I think I think that's probably going to be a common scenario is you don't have the same device in the access layer. You just have a device depending on what your connecting devices are, your endpoints. So like having the access layer contain different devices, I think might make sense. Okay, so let's drop some 3750s VIOS images in the access layer. We'll drop two of those. Okay. Is this it? Uh, um, hmm. I'm guessing it's Nope, we're not using any Arubas. Not using that. Not using any of these. Which device are they even talking about? Now the Nexus we'll definitely use in the data center. I do not see what they are talking about. Is this it? Huh, I'm confused. Oops. So we'll get rid of these nodes and these, and then let's take a look at. So they want the VIOS image. Is that the same image here? No, they want so it's definitely going to be a Cisco image. Is it one of these? No, that's SD-WAN. It's gonna be a VIOS image, something Cisco. So it's probably one of these. I'll just drop all my Ciscos and take a look. Now, these are all SD-WAN. So this looks close, but this is VIOS 2017. So it's not this one. It's probably this one, right? Okay, there it is. So it's the Cisco iOS 2017 one. So we're gonna drop two of these. Yep. And then we're gonna rename them to Access 01 and Access 02. Okay. Yep, that's fine. And then this one. See, the thing is, like, if you have two selected, it'll basically like pick a random order and then apply changes. So like, you have to be careful that you don't have more selected than you intended. All right, this looks good. Bring this up a bit. All right, now we need one more access. We're going to have a diversity of devices on the access layer. Let's say there's different features required due to our final access device, access 03, is going to be an EXOS device. Is that what these are? No. This is the final one. Yeah, EXOS VM version 330.7. Yep, that one. This is it. And this is the Access 03. All right, so we've got our campus set up. We don't have anything cabled up yet, but that's fine. Next, we'll do the data center. I'll take a pause and be right back. All right, I've got a late lunch, early dinner coming up, so I'll set an 8-minute timer. All right, and then hopefully notice that when it goes off. So, yep, we've got the campus network set up. So now let's do the data center network. So we're going to have our aggregation layer, we're going to have Nexus devices. It's kind of like a spine and leaf topology, I think. So the data center is going to be wider than the campus. So let's it's going to be fewer layers. So we can do we can make this we can move this over. There we go, like that. And then we can expand the data center out. All right, and then drop the images. So the first image we're going to need is the Nexus 7K. We need 2 of those. One thing I should do is just go and grab as many images as I can get. I don't think I've done that yet. Like, if we look at the template, and then we, these are all the images. Just go through this whole list and, like, if I can get it, get it. If I can't get it, don't get it. And then the AI just has a lot more to work with then, because I can drop in the images then, and I'll have more images. And I can learn more about, like, these images and stuff. I can learn about, like, why it chose to choose something over something else. I do that off camera sometime, probably. Hopefully. All right, so here's a Nexus. This is Nexus 9K So not the one I want. Here's another Nexus. Or no, this isn't a Nexus. Where's my Nexus? We can narrow it down. A Nexus is a switch. So it's one of these two. Man, which one is it? So it's the Nexus 9. Oh, it is the 9.5. Okay. It's this one. Yep. All right, so we'll place one Nexus 9.5, then another Nexus 9.5. All right, and then I'll rename them. Here, I'll just copy paste this. Okay, and then rename the other one. Okay, looks good to me. And now we gotta drop the leaf layer. So we got quite a few to drop here. We're gonna drop the Cumulus Linux machines here. So 4.2. Yeah. So I think I only have one. Yeah, I only have one Cumulus image. So we're gonna configure. Check. Yep, this is the 420 image. Double check that. There we go. So we need 4 of these. 2, 3, 4. We need to change the host name on them. So we've got DC1. Okay, so we change the host name here. There we go. Then we change the host name to the next one. I've been wanting to do this for so long, but it's like, it's just like, even if you have the CCIE, it's just like so much. And like, I don't know, it's just like without a personal tutor or like someone to like mentor me and guide me through this, it's just like too much. But I have that now. Like this AI has served as like my personal tutor in the way I needed in order to do things like this. Okay, so it looks like I accidentally. Oh, let's see here. So we've got data center 1, A and B, and then we've got so we've got data. Oh, this is weird. So we've got data. Oh, let me go through and Oh, I see. Okay, so is this? I'll say, is this correct? I see a host name listed twice. Is this correct? I see a host name listed twice. Okay, yep, there's a duplicate host name. Oh. All right, so let's do that. Let's name it C. So we're gonna have it be a -C. It looks like there's 3 devices, and of course we'll change this as we actually get down and dirty into the real world examples. But for now, we've got it the way we want it. I just want to drop all the images because that's going to be kind of tricky. All right, there we go. So, looks good to me. That's where I want to be right now. We also need to do the WAN. So, all right, let's do the WAN. So I need to drop that. We'll do the WAN as a circle. It's kind of more of a cloud thing. Or it's like the WAN is like one thing we'll do is we'll put this internet connection in the WAN. No, let's just do a square. Squares are better. Yep, and then we'll call it WAN. Looks good to me. And now we need 2 devices in the WAN. We're going to go with a Viptela Edge, and we're going to go with another one of these just basic devices. So Viptela Edge is easy to get. Yep. Yep, there we go. 1920. And then this is going to be called this WAN Edge Switch. There we go. And now we're going to do just a basic 156 VIOS. I think that's this one. Yep. Okay, and change the host name on that. And it's an ISR, an Internet Services Router, so it's like as if it were in a service provider. There we go. Change the host name. All right, so here's the WAN. I can put the I could put this in the WAN. You know, this is like we're simulating like remote work, so like we're doing this in so we're accessing via, you know, send this to the back. There we go. Yeah, so this like belongs here. We can even raise this a layer. Or sorry, lower it a layer. Or we raise this. Nope, we gotta lower it. There you go. But yeah, this looks good to me. Automation server will just put over here. And yeah, I'm pretty happy with this so far. My timer is expired, so I'll go check on my thing, and I'll be right back. Alright, I'm back. So, yeah, we got this all figured out. We've got the WAN layer, the data center layer, and the campus layer. Here they all are. So the next thing I want to ask the AI is, for each of your decisions that you made to assign an image file to a host name, explain why you chose that image file over another one. Did you need to choose if you had no limitations in your choices, which would be the absolute best choice you could make, regardless of whether or not it is available to choose.
Adding image files to host names in a virtualized network lab environment is often a decision that hinges on various factors, including the objectives of your lab, the hardware and software features you wish to emulate, and the availability of those image files. Here's a breakdown of the rationale behind the choices based on the given scenarios. Access layer, 3750 series, image file. Bios underscore L2 with vendor Prizek 9M. 03. 2017. QCOW2 Y chosen. The 3750 series is a Cisco product, and the Bios underscore L2 with vendor Prizek 9 meter image is specifically designed to emulate Cisco layer 2 switching functionality, which is useful for access layer functionalities. Access layer, 3850 series, image file. Exos VM underscore V3. 7. 1. 1. QCOW2 Y chosen. This is an interesting choice because 3850 is a Cisco switch, but the image file Exos VM is related to Extreme Networks. You may be simulating a mixed vendor environment, which can be very instructive and aligns well with your goals to have a broad view of the industry. Nexus 5K image file. Cumulus Linux 4. 2. 0BXAMB64 Camu. QCOW2 Y chosen. Again, this is a deviation from the standard as Nexus 5K is typically Cisco hardware. Cumulus Linux is used to simulate a different operating system's interaction with your data center environment. This could help do master network automation scripts that need to operate in multi-vendor environments. No limitations. If there were no limitations. For the Cisco 3750 and 3850 switches, the best choice would likely be an image that most closely mimics the latest Cisco iOS version that runs on these switches in real-world scenarios.
Just get all new gear.
That would allow you to most closely emulate the production environment.
Get the latest and
For
greatest.
Nexus 5K switches, you would use Cisco NXOSD images that are meant for the Nexus 5K series, as they would offer the most accurate emulation of features and behavior you'd expect in a production environment. Being well-versed in these different environments could be advantageous, especially for your first major life goal of
5Ks. I could probably get 5Ks pretty easily. Oh, they're not routers. They're multi-layer switches. I mean, this is it right here. Oh, they got microtics. That's interesting. So I'm not sure which these are. I mean, it's like, I think it's the same. It's the thing where, like, you know, whether it's a 5K or 7K or whatever, like, it's not it's not a different image. And like what we're doing here is we're dealing with images, like we're virtualizing hardware. So like, you know, it's agnostic to like the hardware that's actually being used. Like the only hardware we can use is like the hardware we can virtualize. So like whether it's a 7K or a 5K in the lab, the virtualization lab, is only different if they run different images. But if they run the same image and it's just a matter of like what happens when you do a show command, like because it's different hardware, you know, it's there's not going to be a difference because we're virtualizing the hardware. Ooh, I don't have an SRX. How do I not have an SRX? What am I thinking? Oh, it's probably because you need it. Oh, I can get a trial. Yeah, I can get an SRX. You have to call them. All right. Well, maybe for another time. So that looks good. So yeah. Now let's do the wiring next. I'm gonna say thank you. This was absolutely perfect. This was everything I needed. Next, I would like to do the wiring. Please create for me a output that I can use to easily wire up this lab.
Hi. Glad the previous information was helpful for you.
It was.
As you're looking to create a lab for your networking studies, wiring is an important step. Below is a sample lab wiring output, which you can use as a guide to connect your devices. This will involve interconnecting the devices as per their roles in the network architecture. Given your interest in network automation, this kind of hands-on work can provide you valuable experience and practical knowledge.
All right, so here's the wiring guide. What kind of world do we live in now? This is absolutely insane. Okay, so what we're gonna do is we're gonna connect port 1 on the core switch. So here we go. So it's doing it like this. So on the access one, we're gonna connect port 1. It's hallucinating. It's not doing it well. Yeah, it's not really doing it well. I think the wiring isn't that complicated. I think all you do is you connect it to each of the distributions, and then you connect the distributions probably to each other depending on what you're doing, and then up to the core. The data center wiring is where like I'm not that as confident, because especially since we have two data centers apparently, and then the WAN wiring I'm not even that sure. I assume the edge of the WAN goes into like here, and then, but I don't know if it goes into like both of there. So yeah, so this is the data center, and then this is the campus. So the campus, access 1. So where is it getting? Where are you getting this from? Where are you getting from? Please rewrite the wiring guide, but use only the host names given in the host file. This is where like it just can't do fine details. Like it's gonna break down. Fine details aren't really its thing. See, and this is not how you would wire it. No, that's just bad wiring. Yeah, like it's broken. It broke. You can't rely on it for everything. Like this is the kind of wiring we would want. Is like, so like we'd have like one here like plug into like port 0 or whatever, and then we'd have this is probably there we go, and then we'd have like 2 here go into like port 0 there. We could even have them let's do it like this. So we can have 1 plug into 1, plug into 1. Then we can have 2 plug into 2, plug into 1. Then we can have 2 2 like that, plug into 2. And then we can have 3 plug into 2 like that. And then we can have like 12 plug into 12. Like that. And then now we have to make the other connections. So we can have 2 plug into I mean, this is where it gets like kind of tricky. Okay. And then like 11 plug into 0. Like 11. See, like this is the kind of wiring you want. I just know that because I'm a network engineer. So like, it's broken. And then here's where I'm not sure, because like we supposedly had like 2 sections in the data center. So like, do we have this kind of wiring here, but not like across there? Like what limitations do we have when it comes to wiring? Like this, it's telling you to wire it up like that, like all in one long string, and that's not correct. Where can I go to learn about what my data center wiring needs to look like? The wiring guide that you gave me looks like it is just not based in any sort of technical expertise for what the ideal perfect wiring would be for these sorts of networks.
Hi. Understand that you're looking for a more expert, grounded approach to wiring your data center. The wiring guide I provided was quite basic and not optimized for real-world or high-availability scenario.
Right.
Given your interest in network automation and the NCORE exam, understanding proper data center wiring is essential. There are several resources where you can learn about optimal data center wiring. Cisco's Data Center Networking Guide.
Yeah.
Cisco provides detailed guides and best practices for data center architecture.
Well, let me try this. So create for me a wiring guide. Come on. So create for me a wiring guide that is an expert grounded approach to wiring my campus and data center networks. Instead of providing a basic and not optimized wiring guide, provide one that is optimized for a real world or high availability scenario based on the best possible network engineering and architecture methods.
Certainly. Creating a more advanced wiring guide for a high availability data center and campus network requires a deep understanding of networking best practices and industry standards. While I can't match the expertise of a certified network architect, I can attempt to provide a guide based on your specified devices. Given that you have goals related to network automation and advanced certifications like NCORE and LPIC1, a high-level understanding of network design will be beneficial for you. High availability wiring guide note. This is a sample configuration and should be reviewed by a certified network architect for a production environment. Campus area network access layer access 01 and access 02, 3750 series. These should be connected to the distribution layer switches in a redundant fashion.
Here we go.
Access layer 3850 series. ACCESS03 also connected redundantly to the distribution layer switches, but make sure to validate that Axos and Cisco IOS play well together for use case.
Good.
Distribution layer use two switches for high availability. E. G. Disto 1 and Disto 2. Wiring. Connect ACCESS01 to Disto 1 and Disto 2. Connect ACCESS02 to Disto 1 and Disto 2. Connect ACCESS03 to Disto 1 and Disto 2. Data Center Nexus 5K DC01 and 5KA, DC02 and 5KA, DC02 and 5KB. These should be set up in a spine leaf architecture for better scalability and redundancy. Spine layer, let's assume 2 spine switches for scalability, spine 01 and spine 02. Wiring. Connect DC01 and 5KA to spine 01 and spine 02. Connect DC02 and 5KA to spine 01 and spine 02. Connect DC02 and 5KB to spine 01 and spine 02. Best practices. Redundant connections. Wherever possible, use redundant connections to eliminate single points of failure. Use of port channels. Use Ethernet bundling, port channels, for better load sharing. Link monitoring. Use technologies like BFD, bidirectional forwarding detection, to rapidly detect link failures. VLAN segregation. Keep management and data VLANs separate for better security and manageability. Quality of service goes. Prioritize critical traffic to ensure uninterrupted services. This advanced guide attempts to cover high availability and best practices based on standard network engineering methods. I hope this will help you get a better grasp of network design as you work towards your career goals. As always, make sure you're staying on track with your daily Anki flashcards to prepare for your NCORE exam.
Oh, I'm getting a phone call. Please. Let me pause it and take care of this. Alright, I'm back, and I just want to say, like, you know, as amazing as this is a reminder that it's not there yet. Like, it just can't really do the wiring very well. It knows that it should set up in a spine leaf architecture. Like it knows the basics, but it can't just get it exactly right. So like, this is just a reminder that, you know, we're at a time in history which is like so exciting. It's like, you know, this is only gonna get better. And you know, imagine when it does get everything exactly right. Like what a crazy time that would be. It can just design and implement a whole network just ad hoc overnight, based on its own expertise. Like, that's just absolutely a crazy world. So I think this is how you would want a spine and leaf in a data center. I'm not sure if these need to be connected or not. I know you definitely want them connected in a campus for like your control traffic for first hop redundancy protocols. So you know what? I guess I'll ask the AI. In a data center network, do you need to connect the aggregation layer, and by that I mean the spine layer switches together, or do they only need to connect to the access layer switches, the leaf layer switches, and not to each other?
In a data center network that follows the spine leaf architecture, the spine switches aggregation layer usually do not connect to each other.
But that's not the case for okay, so we'll leave it like that. Okay, so and that's not the case for campus. Let's ask about that. But that's not the case for a campus network, right? In a campus network, you would want the distribution layer switches to connect to each other for the purposes of things like control traffic for first hop redundancy protocols. And if you wanted to do VSX stacking or that sort of thing, you would have to have them connect together. So this is a primary difference between a spine and leaf data center architecture and a campus architecture, correct? The difference being that in a campus architecture, the distribution layer switches are connected to each other, but in a data center architecture, the spine devices are not. Oops, I don't have this.
If one distribution switch fails, the other can take over. First hop redundancy protocols, FHRP. Protocols like HSRP, VRRP, or GLBP can be used to allow hosts to continue to forward IP traffic to an available gateway router when their primary gateway router fails. Layer 3 routing. The interconnected distribution.
Okay, great. Now please make a list of reasons why you wouldn't connect the spine switches together in a data center network.
Certainly. Understanding why spine switches in a data center aren't directly interconnected can be useful for your career goals, such as mastering network automation and gaining a bird's eye view of industry standards.
Okay.
Here are some reasons why spine switches typically don't connect to each other in a data center using a spine leaf architecture. Elimination of loops. In spine leaf architecture, eliminating the possibility of loops is a priority. The architecture is designed so that packets have only one shortest path to take, thereby removing the need for loop prevention protocols like STP. Simplicity and scalability. Spine leaf architectures are designed to be simple to understand and easy to scale. Adding a direct connection between spine switches would add complexity without providing significant benefits. Predictable latency. The spine leaf topology ensures that every leaf switch is equidistant from every other leaf, making network latency more predictable. Interconnecting spine switches could introduce variable path lengths and thus latency. ECMP.
All right. Yeah, great answer. Okay, so I'm pretty happy with this. So let's do one more thing. Okay, perfect. I'm really happy with all the work you did. Congratulations. I am really impressed. One final thing, though, with the same kind of expertise and best practices in mind, create a wiring diagram for me to connect the WAN network to the data center and campus networks. Make sure that you are not just creating a simple and basic wiring, but that you are creating the best wiring that a network expert would use out in the real world.
I'm glad to hear you're satisfied with the information so far. This should align well with your career goals, especially the aim to master network architecture and design. Please note that I can't create visual diagrams, but I can describe an expert-grounded approach for connecting a WAN network to your data center and campus networks. Since I can't see your specific hardware or requirements, I'll provide a generalized approach that adheres to best practices. WAN to data center wiring. Primary WAN router to spine switches. Use dual links from your primary WAN router to each spine switch for redundancy and load balancing. Preferably, these should be 10G or higher Ethernet links. Secondary WAN router to spine switches. Similarly, from a secondary WAN router, dual links to each spine switch for high availability. Route redundancy. Implement dynamic routing protocols like BGP between your WAN routers and spine switches to ensure optimal path selection and failover. Coast settings. Apply quality of service coast settings on the WAN links to prioritize crucial data center traffic. WAN to campus network wiring. WAN router to core.
You can see my specific hardware and requirements. It is the lab topology that you designed for me based on the information in the hosts file. Do you remember that you went through each host name in the hosts file and assigned it an image? That is what my LAN looks like. And you designed for me a campus data center and WAN network. But you also designed for me a WAN network. But when you designed it, you did not include information for how to connect it because I did not ask it, but I am asking now. And just please remember that you do know the images that I'm using and then the 3 networks that I'm using. I was able to wire together my data center network based on your output, also my campus network, but I still need to know how to wire my WAN network.
Let's get straight to connecting your WAN network to your data center and campus networks. Based on the host files and images you provided earlier for the campus and data center networks, here's a detailed wiring guide. WAN to data center wiring. WAN 01 router to spine switches, DC01N5Ka and DC02N5Ka. Link from WAN 01 routers gigabit Ethernet 0/0/1 to DC0.
I don't think we had a WAN over WAN 1 like that. We don't have a WAN 1. We have ISR 1. Where are you getting See, this is where it like breaks down. Like you can't like play chess with it. Like you can't like have it build you like remember a chessboard and like put pieces on the chessboard. Like it like doesn't follow the rules. It like doesn't remember what the board was. Please use the host names in the host file. Here is a reminder. Okay. Yeah.
Here's a revised, optimized wiring guide based on the host names you've given. WAN to data center wiring. WAN ISR01 router to data center spine switches, DC01N5Ka and DC02N5Ka.
Okay.
Link from WAN ISR01's gigabit Ethernet 0/0/1 to DC01N5Ka's Ethernet 1/1. Link from WAN ISR01's gigabit Ethernet 0/0 to DC02N5Ka's Ethernet 1/1 WAN to campus wiring.
All right, I think this is it. So, we're going to wire this up to here. So that's WAN ISR01. And then we're also going to do it to 02. All right. And then now we're going to do a WAN to WAN connection. Here. Okay, and then we're gonna do oh. What about the connection to the campus network? It looks like you left that out.
I apologize for that oversight. Let's correct it. WAN to campus network wiring. WAN ISR01 router to campus access layer switches, ACCESS01 and access 02. Link from
No, sorry, they had it. So it's like ISR 1 is going to, but that doesn't make sense. You have to do you can't have ISR 1 go to both, because like that's the point, is like they're not together. So you have to have yeah. Oh, yeah. Yeah, it's not doing it right. Yeah. Anyways, this video is going long, so I'm going to stop it. Thanks for watching and see you in the next one.